Today we're going to share with you this very, very cool diagram. It's one of Scott's, and it's based on this thing called the Kepler triangle. So you don't have to worry about what that is, only that it's a very specific Pythagorean triangle that involves this kind of magic number, the golden ratio, which is called phi, okay? And you have the baseline is simply 1, and then the two sides are the square root of phi, and the hypotenuse is phi itself, the golden ratio, okay? Don't worry about those details. I want Scott to come in here and explain why this triangle is particularly cool and what it marries.
Well, this diagram is illustrating why it's cool, and that is that it encodes the size of the Earth and the Moon together. So if we take the diameter of the Earth as one unit, and then we bring the Moon together with the Earth, we see that the combo is the square root of phi. And this leads to this triangle, and it also leads to the circumcircle around the triangle and a square that's made out of that triangle's height. And it turns out that the square and the circle are equal in length. So this is an example of squaring the circle. And I believe that happens because the square root of phi is very close to 4 divided by pi. And that's kind of a mathematical side note. But what's amazing is that this is unexpected. Our planet and the Moon shouldn't necessarily follow a simple geometric diagram, but they do. It's 99.9% accurate. And
that's the thing I think is cool, is like, you know, I love the way you put the Earth down on the baseline, you know, and this is obviously like you could call this like a super famous triangle, couldn't you? The Kepler triangle. It's like it's a well-known archetype. And
well, it's a very special, unique triangle that Kepler, who discovered the laws of planetary motion, put his name on this particular triangle, and it's kind of a mathematical curiosity as well. But that's not where it's at for me. What's amazing is that this simple triangle encodes the geometry of our planet and the Moon, and that's
so cool.
It shows me that geometry is underlying all things. And that like golden ratio is like this template that is beyond the physical, and it's what a lot of things like a sunflower uses the golden ratio in it. Okay, in terms of the seed pattern on the sunflower, because they're arranged in Fibonacci numbers, and the Fibonacci sequence is intimately connected with the golden ratio. But it's sort of like I think of it as the physical manifestation of the golden ratio, because you can't have 0.618 seeds. You can either have a seed or not. And so that's where the Fibonacci sequence comes in, because it encodes things in discrete ways with integers.
Sorry to jump in there, but you mentioned as well that there's a component of this diagram that gives us a square and circle of the same length, right? What I find interesting about that is oftentimes there's geometry that we present here that brings a squared circle to us through the relationship of our Earth and our Moon, planet Earth and the Moon. This isn't the first time we've seen a squared circle between our Earth and the Moon. So like archetypally, this squaring of the circle seems to be linked to the Earth and the Moon. What do you make of that? Like, is there anything we can speak to? Earth,
the archetypes
square.
Of the square and the circle, to me, evoke the square as a mundane thing you can easily measure and lay out. It's very close to humankind, whereas the circle, it represents the divine or the transcendent, where you can never really pin it down because it's based on pi, something we don't really understand, and we're always trying to calculate more digits of pi, but we can never come to the end of it. It's just like the perfection of the dome of heaven, or of the circle, the circle of the planet and the circle of the Moon. It encodes this kind of unknowable quality in it somehow, and yet we can bring it all down to something we can understand with the square. And so this Moon and Earth system encodes that kind of tension in it, and I find that that's just really unexpected and really beautiful.
Mhm.
And I'd
It's
love to hear
fascinating.
what you guys think about it in the
Yeah.
comments.